Okay, good afternoon, folks. Welcome to the V6OPS session. So my name is Xipeng Xiao. I'm one of the co-chair, and my other co-chairs, Ron, is online. Nick will be online. So now it's odd hour in the US. So I want to thank my co-chair for their support. Today so first let me go through the note well. So by participating in the IETF, you agree to follow the IETF process and policies. If you are aware of any IETF contribution and is covered by the patents or patent applications that are owned or controlled by you or your sponsor, you must disclose that fact and not participate in the discussion. As a participant in or attendee to any IETF activity, you acknowledge that written, audio, video, and photographic records of meeting may be made public. Personal information that you provide to the IETF will be handled in accordance with the IETF privacy statement. And as a participant or attendee, you agree to work respectfully with other participants. Please contact the OPS team if you have questions or concern about this. We always like to remind everybody that we work as individuals and try to be nice to each other. So if you have not logged in to Data Checker, please scan the QR code to sign the broadsheet. Also, please use your mobile phone to get into the MeEco queue before walking to the mic. So today we have 3 working group draft and 3 individual draft. The allocated time is 100 minutes, while we have 100 minute, 20 minute session. So we may give each draft a little bit more discussion time if needed. Looking at the working group, basically the number of drafts have been relatively stable, but we also noticed that in the last 3 IETF, the number of attendees has dropped compared to the previous 3 IETF. We are wondering why. Maybe it's because of meeting location. Maybe it's because in the past we are having the operational presentation. But if you have any idea, why this is the case, maybe you can talk to the chairs, because we are indeed interested in getting more people to attend the V6OPS session. In terms of the working group milestone, we are slightly behind because the number of drafts that we tried to publish last year have not all been published. And also the IPv6 MOPS, I think that JNU folks want to, after the Madrid IETF get some more experience before you request a working group last call, if I understand you correctly from the mailing list. So overall, I think that we as a working group is slightly behind schedule, but I think that it's manageable.
Sorry, I didn't know we have deadlines on this. We need a project manager then. Yes, so MOBS draft has been stable. So basically, I put there everything I know. But for example, this Sunday we heard from Cisco Life Experience on this. And and Warren promised us that in Madrid we're going to see V6 mostly as a primary SSID. So I think we might find more exciting news and recommendations how to do this. So that's why we're not even presenting the draft this time, because basically it was very little changes to it. But I think it would be too early to ask for the last call, because we can expect more input. And maybe after, and as far as I know, on Friday it will be a side meeting from 9 to 9:30 about V6 mostly, a NOC experience and this IETF. So yeah, I think we'd like to get not experience. Yeah, so and so I think it would be beneficial to get more people who implemented this to come and at least confirm that what is written in the document is right. And if we will agree, then yeah, we'll ask for the last call.
Yes. I want to be clear that we are not blaming anybody, and if anybody are to be blamed, it's more the chairs. Yeah. Then I'm just compare our where we are to the milestone we set, and saying that this is the kind of the fact. Again, we call for contribution to some important works. These including the milestone works. These including Brian Carpenter's book. Here, I would like to add maybe something new, because nowadays everybody is trying to link their work to AI. For the IETF, these have not been easy, because how exactly to link the practical works to AI have not been easy. But for us, the operations working group, maybe we have more opportunity of flexibility. So here I would like to share a little bit of work that one of the challenges of deploying IPv6 have been that IPv6 involve many RFCs. It's not so easy to understand all these 500 RFCs, including the user manuals from the vendors, etc. So this is not easy for human, but this is not too difficult for AI or LLM. So we did some analysis trying to use LLM to answer IPv6 questions, the factual questions. For example, you can find the answer from RFCs. We tested 3 LLM from China, the leading LLM from China and from the US. The long story short is that first, many of these LLM can answer factual IPv6 questions very well. The accuracy rate is usually above 90%. The second point is that compared to IPv6 engineer, in terms of like answering factual questions, actually AI can do better than human. But we move on to try to get LLM to produce, for example, lab configuration, etc. LLM have not been able to perform very well yet, and we are trying to figure out some ways to do this. Again, we feel that this may be some interesting work that can attract people to V6OPS. If any of you are also doing some of this kind of work, maybe we can, for example, hook up with each other and maybe share the lessons we learn. Go ahead.
Tommy Jensen, Microsoft. I would like to see the IPv6 engineer also broken out by geolocation. Yeah, because I think in all seriousness, that might be an interesting way of saying, well, who should we be recruiting for more working group attendance from if we find there's a gap in IPv6 knowledge somewhere, to really give the AI comparison a apple to apple or mango to mango, as it were here.
Well, we believe that maybe the region is not that important, but it's a fact that 500 RFCs is not so easy to remember. So again, it depends on how much Google work you are willing to do before you answer the question. But if you just answer the question with your brain, actually it's not easy. Okay, I think that these are some interesting information to share, and we have other interesting work to, again, for example, to maybe hopefully getting some stats from Happy Eyeball, so that we can figure out why sometimes we are not using IPv6, etc. Please.
Q Meisel, Max Planck Informatics. I have a very short response to using LLMs to answer technical questions of this kind. No.
It's okay. Okay. Yes, I think that different people have different opinion, but yes, Warren.
I mean, yeah, initially when I saw this and I was reading, like, this is dumb, this is dumb. And then I saw the comparison to an IPv6 engineer. And I was like, oh, maybe it's not quite so dumb. Potentially having something where you ask it a question, see an answer, and then you can learn from the answer might be reasonable. Not generating your configs from the answer, but having you can learn stuff by, like, this is what, like, making humans better, not generating the configs.
Tobias.
So Tobias Fiebig, Max Planck Institute for Informatics. I'd like to apologize for the brief answer of my advisee and would like to expand it a bit. I personally believe that the use of LLMs might be an interesting endeavor besides the work going on in the working group, but looking at the agenda that was put out before concerning the milestones and objectives, I would argue that there are objectives that are most likely of higher priorities than LLMs.
Fine. We haven't added this to the working group milestone yet, but I just feel that this may be interesting to attract people, attendee, or work to. Yeah.
I think what's more interesting than maybe an LLM's ability to provide answers that a human may not have done correctly is to figure out what kinds of questions the LLMs are getting right that the humans are getting wrong as an identification area of where we should be doing informational RFCs or better education or do an IPv6 learning track. I remember a couple IETFs ago, they did a big BGP learning track that was actually really cool. Like, this could help us uncover where that could be best spent.
I can press. Yeah, we need to find out how quickly LLM can press the button, join the queue. Yeah, so sorry, I'm still trying to join the queue. I would like to clarify a question. Everything except the last column called large language model, right? What was your data set for IPv6 engineer? Was it one engineer?
Yes. No, but let's let me put it this way. You can say that, oh, this is not very scientific. This is not 100% accurate. Yes, I acknowledge all of that. But I just want to share something that, this LLM, we can do something, because at the moment I feel that, in the industry, many of the people try LLM and say that, oh, there are problem here, there are problem there, so it's not ready, and let's wait. So of course you can wait, but at the same time, I think that it will be good for us to really work with it and figure out, how we can make it better and use it. Because for IPv6, one of the key problems is like, there's not enough, people with good IPv6 knowledge. And LLM can definitely help. And if we simply ignore that, I just feel that we are leaving money on the table.
So Tobias Fiebig, Max Planck Institute for Informatics. What I would also like to caution is that LLMs tend to be creative, which can put additional strain on our limited resource of IPv6 capable engineers into the fine nitty-gritty details. For reference, when LLMs took up prominence, I had a very lengthy discussion with a student, not present, that was convinced that there was a certain configuration option in Power DNS. And when I asked for the documentation, I got quoted documentation. And when I further looked up, that was actually DNS dist, like the recursive component documentation, kind of rewritten to be for Power DNS, because of course it was not the search function being used for the documentation, but an LLM.
Okay, I think that we need to move on, but let me just maybe add one last sentence, that because LLM, it never get to 100% accuracy. So the intention is definitely not to, replace any human engineers here. So let me make this point clear. Okay, now let's move on to our first presentation.
I tried. I didn't succeed.
Okay. Come in.
Thank you. All right. Okay, enough about AI. Let's talk about CLAT. Is the side button? Yeah. Yeah,
No,
next.
hold on. Okay.
Excellent, thank you. All right, so we made a bunch of changes in the last 2 revisions since the last meeting. First off, clarifying that CLAT source addresses have to be treated like any other address, just to clarify consistent behavior. You got to do duplicate address detection, et cetera, et cetera. Everyone can read. Multi-homing. We're trying to keep our nose out of everyone's business. Some basic guidelines of not creating multiple CLAT instances for the same tuple of unique PIO and NAT64 prefix. But you can do either multiple instances or one instance for different tuples if you want. That's an implementation detail. And should use the configured logic for choosing source addresses, which helped us get around a reported issue of the wrong address being selected, which puts the power back into the admin of the stack to do as they see fit without us inventing some special case. Lorenzo.
Is there any aspiration that deployed code will implement this, or is it sort of more of a greenfield, future-looking thing that you're writing here?
As written, I would expect this to be not greenfield.
I see. Well, your expectations are incorrect. But okay. I mean, I agree with this. I think, like, just as an example, the Android implementation will send a DAD packet, but it will ignore any responses, and it won't do any source address selection of any sort. But you know, it's but like, I think it's fine to write it down. It's just like, you can't really, if no implementation does it, it may be difficult to validate it, I guess.
Janlenko, as a network operator, I would definitely go in to ask at least some implementations to do this. And again, it might be not very useful for every device and every scenario. And you're probably thinking about mobile phones. I'm more thinking about wired workstations which move in between VLANs. And it might be different case, but I still think it's useful to define behavior which is in general implementable, at least for like workstations, and it's not too complicated, because as you remember, last time we spent like 20 minutes discussing what to do with multi-homing scenario, not 15? Okay, so yeah, we spent some time on this, right? And we're trying to find the balance between making the logic overly complicated, but still useful, right? And cover at least normal scenarios of, let's say, 2 routers on the link.
In that case, maybe does the text have like some like bug reports in disguise? So like, you know, there's a DHCP6 RFC that says, you know, whatever, observed incorrect implementation behavior or something. You don't have to go that far, but say, you know, if you don't do this, insert current Android bug here, or if you don't do this, insert current Apple bug here. No, about all of like things like, you know, source address selection or like DAD or something, right? Explaining why these, you know, what it might be worth explaining, even though no implementation like does this correctly, we might want to explain why we should do it this way.
Fair point.
Let's say like, you know, you should do DAD because otherwise, the reason we send the DAD packet and we don't look at the response is that on some networks, if you don't send a DAD packet, your address doesn't work. And so we broke the Facebook corporate network or whatever, and then we fixed that. But like, it's really hard in our implementation to listen to the response, so we don't. But you know, that kind of thing. So you know, then because like just saying, oh, should do this, and people are like, oh yeah, I have a good reason. It's really hard to implement, and you say, well, should do this because otherwise.
Thank you. That's good. That's a good suggestion.
David Lamparter, just clarification on the last point on the slide. And since Lorenzo just mentioned doing source address selection for the CLAT, this is about earlier, as in setting up CLAT to begin with, right? You're supposed to have that influence the setup and everything. This is not about the CLAT selecting when it's doing actual traffic.
Yes. I mean, you're correct.
Yeah, you're correct. Basically, the question was, we have a logic in 6722 how to select addresses, but now you have multiple PIOs and you want to select which PIO you're going to use for address. And we were like, why do we inventing new stuff? Let's reuse the same logic with the same policy table. So Lawrence, answering your question, you know that saying about doing what's right and not what's easy. So well, we definitely can add more text, but I can tell you that the statement about please answer to a unicast solicited an access for an address is not just I was bored and didn't know what to write else. This actually came from real implementation bug when CLAT address disappears from the router cache from time to time, causing actual timeouts and visible user impact on WIF-only applications, which might be good. Maybe you want to penalize them, but if you don't do like the full neighbor discovery implementation for CLAT address, you're gonna have a hard time and users will be unhappy.
All right, so the next change we made was same configuration for default source address selection when choosing between PIOs, which is just an expansion of what we've been talking about. But with these explanations added to the text to talk about which use cases justified this so that everything will just work. When you're using the well-known prefix, non-ULA goes over ULA for the local PLAT case that was reported. Network-specific prefixes staying within their range, and managed environments giving the admin control without having some made-up mechanism or trying to decide how we should do it by saying, change your policy table. We don't need to do something specific for 464 XLAT. Handling link renumbering. Pay attention when these things happen. Something that we kind of assumed was a good idea, writing it down, which Jen alluded to a bit just now. And finally, thanks to Eric, remembering that, hey, it's 28 bytes, not 20. Straightforward. Oh, no, that one bullet has a comment.
No, it's great to know that people didn't just copy our code, because the Android implementation did this in 2013, but it's good that people just wrote it independently.
All right, and then there was a recent rev to add a formal update to 6877, the original definition of CLAT, to avoid reserving entire source address prefixes for translation. The host having a prefix has value. Source CLAT addresses don't need to be full.
Yeah, just clarifying, yeah, because I think people are confused. 6877 saying without using capital should, but I don't think it's using normative language at all, that host should acquire /64 for CLAT. And this obviously is very unusual deployment scenario. And to be honest, it does not make too much sense practically. So we're saying that we're updating this, saying you should not do this, which means you still may if you really have a good reason. But by default, it just acquire an address for IPv4 address of an instance.
In the original author's defense, I think what we're actually doing is clarifying, because that could be read as you should acquire 64 because you're doing all these things, not just for that purpose, but we're making that crystal clear. Okay, so raising the current open questions after burning through bugs, there is a recent discussion on the mailing list about adding consideration text for environments that only give devices a single /128, and how to give guidance in this situation, because right now the draft says you should acquire a prefix from which the host can select addresses, choose to generate a checksum neutral address for various reasons, and have not given guidance for when no prefix is available. And as another question, as Jen pointed out, 6877 has no normative language other than when it's quoting another document when it's defining terminology. And last time we talked about wouldn't it be nice if CLAT was a standard or promoted. Seeing as how the normative language for CLAT behavior is coming in this draft, should it be proposed standard instead of its current informational status? Open question to the room. Queue is built.
For the proposed standard question, I think, yeah, given that there are a bunch of bugs in the current deployments, saying proposed standard seems useful to sort of at least, try to like nudge those bugs out of existence, right? We can nudge implementers a little bit better, right? If there's, bugs. And I think it's important. This is sort of getting to the place where it's really interop. Like people use it, it really needs to be interoperable. Like while you're using it in like some cell network, which is very well controlled and like very conformance tested by the operator, it's less important. But like you're putting it on general Wi-Fi, it needs to be a little bit more interoperable, right? For a single 128 case, let's please not open that particular can of worms. There's an RFC that says, there's a BCP that says, don't do this, right? So 7934 says, do not ever like give a general purpose host a single 128. And it says, there's other ways in which you can do that. So I would prefer not to. There's also a bunch of complicated, very complicated issues that you have to deal with in how you implement this. I think as far as I can tell, you cannot implement CLAT kind of somewhere in the packet pipeline. It has to be like deeply integrated in the stack completely. It has to be like part of like socket matching and everything. It's much more complicated to implement. And so I would just steer away from this completely.
And to be clear, do you mean steer away as in don't change any text, or specifically steer away from supporting this and reference the BCP you mentioned?
Good question. I think we should maybe basically say that like it should be using a dedicated address, right? Because like I don't think, yes. Because like I don't know how you would even do 6145 with a shared address, right? It's not stateless anymore. It's like all sorts of like stuff just doesn't really work. I mean, yes, you can hack it together perhaps, but it's not really 6145, right?
So Warren Kumari, Google. On the last point, I think if you're ever not sure between informational and PS, go for PS, because that way at last call or, at ISG eval, if people are like, this was the wrong thing, you can always go down a level. Going up a level requires a whole new IETF last call and 4 weeks in FAF. So always err on the side of PS if you can't decide.
Fair point.
Other people in the ISG will probably wildly disagree and beat me, but I'm only here for another 4 hours, so what do I do?
4 hours and ticking. So if you don't mind, I will take my delegate seat here. I think it's BCP is the best one. You don't change an existing standards.
Jordi Palet. I am for proposed standard. My only question is, we are only standardizing the CLAT or somehow the complete 464X LAT? I think that should be made clear. I will prefer the complete 464X LAT.
Fair point.
NAT64 is already standardized.
NAT64 is.
Yeah,
is there any different like considerations for PLAT specifically? Anyway,
yeah,
it's a fair question. Yeah.
Jordi, I think like we have it's been mentioned, NAT64 is standardized. This is the second part, and now you have a standard. How you build those elements together, I don't think we need to standardize that because it's a deployment scenario. I don't think it makes sense to write a standard on deployment scenario. You can put this together, fine. How you operate this, like how do you build them, and it's already in actually 6877. Actually, I came here, I'm here actually. Lorenzo, I would really appreciate if all those concerns about complexity of using single address would be sent on the list so we can copy them on the draft and explain why we should, especially in the light of the most recent ISG guidance on normative language, why it should or must be done.
Philip
Thiesel. So on the /100 and /128 question, from an implementer's perspective, I totally get why you really don't want this. I 100% get this. But from a deployer's perspective and seeing how much hassle it is in a big corporate to get something else than DHCP V6 deployed, I would say
we were
doing
told DHCP6 supports more than one address.
Yeah.
Everybody swore that blind, and it's like, oh yeah, you can use DHCP6 to get multiple addresses.
I will try this at home, and I'm pretty sure the NUC will prevent that, and a lot of other things in the chain too. So I think if you say no 100, not a single /128, this will limit the deployment at least in speed. I would say it would make IPv6 mostly at least 5 to 10 years slower. This is a consideration we have to keep in mind. On the other thing, please go for proposed standard. I really would love to see this one standardized, not being one of these gaps again.
Thank you.
Different topic, Lorenzo Colletti. So 6877 is, I don't think this document has almost anything to do with 6877, right? So this is not about like elevating 6877 or promoting it, or it's just a completely different document. So I don't think we should be tied by the same, the same
track.
The same track or anything really. It's so there was a question around like when we did 6877, which again is completely different. Right, there was a lot of pushback against using any sort of normative language in an operational working group. I don't know if the views have evolved there, but that was, I think, but I don't think BCP is the right status, because if we're talking about here's how you should implement it to avoid certain operational issues, then that's either sort of informational or proposed standard, I guess. I would vote proposed standard.
Suresh?
Oh, I didn't see you there.
No, it's okay. It's okay.
Wow, we're being really nice to each other. Speaking of being nice to each other, I just realized my comment to Jen sounded pissier than intended. What I was actually meaning was in ops groups, we should also write documents that explain to people how to put all of this stuff together so it actually works, right? Like we have a lot of documents of you have this building block and this building block, but some more things of in order to deploy it, put this block on top of this block and paint it purple.
So bringing that back to suggested text changes, are you saying that as a result of that, we should say something about how this is to work with NAT64? Or
possibly, or I was actually pushing for we should write more documents in general.
Different document
to tell people
for
how to use all of this stuff.
Okay.
So general, like, please let's write more how to actually deploy V6 in the real world.
Jen is so excited for those online.
Yeah, she cannot keep her mouth shut, so she gets more work. So yeah, to answer Krishnan. So for the 64/128 thing, I specifically don't want any text here that would like invalidate existing implementations, but I like the idea of like what Jen was saying like, hey, like, if you can start documenting what could go wrong if you just have a 128, I'm fine with that. And pointing to the /64, right, is also fine. But like, just make sure that like you don't write like don't do this anymore, because like there is like implementations out already. Thanks.
Fair point.
Jordi Palet, I think Lorenzo mentioned something, but I am not sure. And after sitting, I reminded myself that I am not convinced that the recommendation and modification of the 6877 about the dedicated source prefix is good. You mentioned that as well, right? So that will mean you need to do a NAT44 before. You are not talking about that?
No.
Yes. If you need yes. Only in the host. Okay.
Yes.
Okay.
Yes.
I think that should be made clear, because if we modify 6877, it may be read as in both cases, router and host. Yes, and I will read that now.
I think it's clearly saying that we're talking about difference between
yes.
dedicated prefix model versus host model. I think if you think the draft is unclear, please propose the text.
Yeah.
Okay, folks, we need to move on. Yes, the next one is from Chongfei.
Hello, everyone. I'm very pleased to give a presentation in V6OPS again. This is about framework for multi-domain IPv6 only, underlying network and IPv4 as a service. Yeah, this document is elements illustrate how to build a large-scale IPv6 only backbone network for operators. So it's mainly from a perspective of network operator. It also proposed to efficiently support IPv4 service based on the stateless IP address mapping in multi-domain IPv6 only network. This draft is the information document with the new protocols design in this draft. It was adopted 2 years ago. So in this framework, each P devices at the edge of the backbone is allocated at least one IPv6 mapping prefix, such as prefix 1 or prefix 2. And in each P devices, also IPv4 address block will be extracted from the local IPv4 routing tables. So the relation between this IPv6 mapping prefix and IPv4 address block is called mapping rules. This mapping rules give the locations or direction of IPv4 address block in IPv6 only networks. So at the forwarding layer, both encapsulation and the translation can also be supported based on these address mapping rules. For the incoming IPv4 packet, it will be translated or encapsulated into IPv6 packet. So the new IPv6 address will be based on the address mapping rules just by appending the IPv4 address to the IPv6 mapping prefix. So with this approach, there's no need to maintain user-related status at the edge of network. So it is suitable for large-scale backbone networks. Since last IETF meeting, the following revisions have been made. First, based on the comments of Xipeng, the following scenario, a new scenario is added. That's scenario 4. It's about IPv4 user access to IPv6 service. And we also added the illustration of user status in section 4. Generally, user status refers to the address port mapping relation between different protocols, for example, between IPv4 and IPv6. So it uses generally with stateful at 64. One IPv4 address is multiplied by multiple IPv6 addresses. Section 6.4 is moved into section 6.1 so that the readers can have an understanding of the overall procedures. So for the comments of Xipeng about the correlation between different departments or even different organizations, so this approach does not need a correlation between different departments or even different operators. Mapping rule exchange can be based on between P devices, the different AS is addressed through the extended MPBGP protocols, which we have a working group document in IDR working group. We also give the change to the section of IPv6 mapping prefix allocation by adding additional illustration for network-specific prefix. We also made several editorial changes. This draft is based on a field trial in our network because actually operating network include metro area network and mobile core and backbones, multiple domain or multiple AS. So we have deployed this IPv6 only edge at our metro area network and cloud DCS networks, etc. Based on our experience, we found that this is compatible with existing techniques such as for cis4 axolates. And it can be extended to networks which consist of multiple AS or operated by multiple operators. We express our thanks for the comments received from Xipeng and lot of people. Thank you very much. And we think this document is stable for a long time. So we apply for last call this draft. Of course, we welcome all any new comments, the suggestions. This is it.
David Lamparter. I'm going to phrase this as how much discussion did I miss about making this specifically to always have the IPv4 address in the last bits of the IPv6 address? Is there a lot of previous context that I'm missing, or is this? Because, so the reason I'm asking this is whenever you try to route in the V6 domain beyond the first 64 bits, you will significantly increase the cost of the routing lookup in any device involved along the path, to the degree that this can seriously hurt performance. With NAT64, the decision to support different prefix lengths was arguably pointless because the NAT64 gateway tends to handle the entire IPv4 space. In this case, however, you're explicitly targeting a situation where parts of the V4 address space can reside at different exits from the network. And if you want to actually route that differently in the V6 only part of the network, having these bits that are necessary for that determination be further up in the prefix can in fact be beneficial. So I'm not sure if I missed all of the discussion about this or if it hasn't come up yet, but I'm not saying this is necessarily something that needs to be addressed, but you certainly need to be aware that this can cost on your routers.
Yes, actually we have considered this cost overhead to our routers. So we use status mappings about address. And it does not require to say user-related status at the edge of network. I think this is maybe the most efficient way for building IPv6 backbone.
I'm not talking about introducing state. I'm concerned.
State may cause overhead or workload to the network device, to the routers.
So I'm concerned specifically about the fact that most silicon, if you do a V6 routing lookup, you have a 64-bit lookup key and not a 128-bit lookup key. So that's what this is about.
Okay.
I'll take this. I'll send this to the list as well.
Yeah, this has lots of discussion in IDR working group. Maybe you can chat in that working group. Okay, thank you.
So, Chongfeng, this morning I sent you some comments.
Okay.
I'm not sure you have the opportunity to see it yet, but I believe that how the P router, in the middle of your autonomous system, can figure out where to send the packet to the next hop, need to be clearly specified. Okay. So I think that we should probably, talk about it then before we discussing a working group last call.
Okay, I will check my mail. Okay.
Any more question, comments? Well, otherwise we'll move on to the
Thank
next.
you.
Then it's you again.
Hello. Please pay attention. This is a very interesting case of a working group document being presented in the working group for the first time. So how did that happen? So let me, a bit of the history in the context. Long time ago, people started deploying V6 only networks. To deploy V6 only networks, you need endpoints to discover what NAT64 prefix is used in that network. Because otherwise you cannot do local synthesis and all other nice things. So more than 10 years ago, RFC 7050 was published, which suggested to use DNS 64 because you still need DNS 6.4 to allow V6 only hosts to talk to with only destinations, and use the DNS 6.4 to discover not 6.4 prefixes by resolving a well-known IPv4 only name, IPv4 only ARPA. That document contains, among other things, some discussion on security considerations regarding what kind of attacks might be implemented in that case. So in 7 years after that, different variations of using DNS have been developed. We start using DNS over large variety of protocols like DNS over TLS, HTTP, QUIC, and so on. And as we were doing this, those implications of using DNS 6.4 became more and more critical. So at some point of time, like 4 years ago, we published another method of discovering Pref 6.4 when the router can advertise your Pref 6.4 in array. So you get Pref 6.4 in the same packet as all other information. Meantime, the more people deploying IPv6 only networks, especially with all these advanced DNS security mechanisms, the more people notice that DNS 6.4 is not always a good idea. So last year, Tommy finally realized he needs to do something about that. So Tommy came to DNSOPS with a draft which proposed some improvements to 7050. So 7050 could be used together with DNR and become much more reliable. So, however, the feedback from DNSOP was, why do we need to have 14 competing standards? Let's just get rid of 7050 completely. Good. So Tommy recruited Nick, and they wrote a draft about how to get rid of 7050 and came back to DNSOP. And DNSOP saying, oh, who cares about all this V6 stuff? So please go to V6OPS and do it there. So you are here right now. So in December last year, this draft was adopted in this working group. So here I am presenting this. So what exactly problems, what problems 7050 has which we're trying to solve? A number of them. First of all, 7050 expects the host to use network provided resolvers, or if the host or application does not use network provided resolvers, they need to implement RFC 8880 and treat IPv4 only ARPA specially, and then use network provided resolvers only to resolve IPv4 only ARPA. As I discovered in a very painful way, it's not the case for many operating systems. And any other modification of host or application DNS config does not work very well with 7050. So if you have custom configuration or your enterprise DNS config, or you have VPN, which overrides your DNS configuration, it's all starts falling apart. Second problem, obviously, is that you introduce additional delay because you need at least one RTT before you get the prefix, which means it's at least one RTT before CLAT, for example, can start, and before all this with-only applications starts actually getting network connectivity. And meantime, those applications might fail or report some issues and so on. So, and users are getting more and more impatient, and they don't want to wait seconds anymore. Other issues. When a host discovers Pref 6.4 via 7050, it keeps that information and only does rediscovery in 10 seconds before the TTL expires. So if you use external DNS server, which you do not control the TTL. So, and I think I checked Google DNS 6.4, it's like we're talking about 6 hours or something for IPv4 only ARPA. So it's like a long time. So if you want to plan any changes, it will take you hours if you do not want to disconnect the host. And obviously, if it was an attack and someone spoofed your IPv4 only ARPA quad-A record with a large TTL, you would need to disconnect the host to clean up the cache. And on my favorite topic, IPv6 multi-homing. That's not going to work very well anyway, right? As long as you, because host's supposed to ask all DNS servers, get all quad area cards, discover all prefixes, and use all of them. So if you have multiple exit with multiple DNS 6.4, or God forbid you have only one exit point using NAT 6.4 and one does not, it's not going to work very well, right? So another problem is security, obviously. If you do not have a secure channel, whatever it means, it's very easy to spoof the answer and tell your host that, here is your pref 6.4, please use it. And attacker might like execute a denial of service or redirect to some other attacks, right? What is secure channel? 7050 is very hand-wavy about that, so I guess that's why Tommy wrote his first draft initially, right? It's 7050 saying, for example, you can use IPsec to your DNS server. Never seen anyone doing this. Or you can do L2 encryption, which is even like more exciting proposal. So to make the long story short, this draft is actually very simple. It comes down to two recommendations. One for people deploying IPv6 only networks. So please provide pref 6.4. You might currently still need to provide DNS 6.4 as a backup method because it might be hosts which do not do pref 6.4 yet, but please ensure that the primary method is available currently. Ted, okay. So please ensure that pref 6.4 is available as a first method for hosts which support it to implement, to discover pref 6.4. For clients, for implementers, we strongly suggest that they should obtain a NAT 6.4 prefix from array first, if it's available, and then just ignore 7050. So basically, the goal is any DNS people in the room, I know DNS people hate DNS 6.4, right? So it's so many problems with them. But to get rid of DNS 6.4, we first need to do make before break and at least make sure that V6 only hosts support pref 6.4 and do not rely on DNS 6.4. So this is the first step, right? So we suggesting if you're implementing such a host, please add support for pref 6.4 and you may use 7050 as a backup. I've been presenting this in a number of places, and we got some feedback from mobile network operators who say, no, what is your pref 6.4? First time we hear about that, and we don't want to do this, and 3GPP standards do not mention pref 6.4, so we just want our DNS 6.4 stuff. So currently, yes, it looks like it's unlikely that mobile network operators would do this. However, I am now like very excited learning about 3GPP standards and documents and all this stuff. So we might want to start talking to mobile operators to find out how we can promote them to use pref 6.4 as well. But yeah, currently we explicitly saying, yeah, those recommendations might not right now be directly applicable to mobile networks. So yeah, we can continue doing this. But at the end of the day, the goal is let's think about how we can sunset DNS 6.4 whatsoever. So in case you read the draft during the adoption call, we've made minor changes to it since adoption. We clarify that VPN use case is one clear use case of third-party resolvers being used. Described multi-homing implications, added this mobile network consideration section, and done some editing. So you can see div here. And you know what? I think we can ask for the last call because I think we put everything we want to put in this text, unless this long queue going to tell us what we're doing wrong.
So Ted Lemon, no, you're not doing anything wrong. FYI, the Thread Technical Committee actually specifically considered this issue, and we had been requiring DNS 64. The current thread spec, I believe, or at least our decision was that the thread spec would stop requiring DNS 64 and only recommend pref 64. So if you have a thread border router and you're trying to connect it over your mobile phone, it won't work. Sorry.
Fine with me.
Yeah, no, I mean, that's actually, I hadn't thought of that case, and I was actually going to get up to the mic and ask you if you knew of any cases where this wouldn't be a good idea. I think we still probably shouldn't do it, but I mean, I think in other words, the current decision is the correct decision, but this is an interesting data point. So thank you.
Okay, Jen, I'm not going to make you happy. Okay, so
we need to talk, I know.
Yeah, so I have a concern here. Okay, so this document suggests change in behavior of 8781 implementation, like because it puts a should for the what it should do, right? And I think it's inappropriate for a V6OPS document to do that. And that's the bad news.
Wait.
It said like a host should take the 8781 before 7050.
It already says that.
That's what I'm saying. It's
the 6-man. The RFC already says.
That's what I'm saying. So that's what I'm saying. So the good news is it already has a preferred order. It actually says that it actually says do PCP first, right? So we like okay. So right, like so it's PCP pref 6.4.
Yeah.
So this text in this draft is not necessary to say it's a should for it to do it. You can take it off. All this needs to say is like operators should advertise the pref 6.4 in RAs. I think that's all the draft needs to be, and it covers everything. Like I really don't see what else it needs to say. Because like I'm totally with the idea, everything is perfect, awesome, you can write all this cool stuff, but the only thing it needs to say is like operators should advertise this. Like what am I missing in that case?
So yeah, I totally agree that the draft might sound, it actually is kind of redundant. We want to have a separate document summarizing one particular like set of recommendations for both sides, because the problem is we have chicken, everything in V6, right? We have chicken and egg problem here. As an operator, I actually would love to stop sending DNS 6.4 to my hosts, but there are certain implementations which do option 108 and do kind of CLAT, but they still do not pref 6.4 because they're like there is 7050 here. So we want a clear signal to those implementers, right? Not operators, that 7050 should not be used. Please stop doing this. Please consider only pref 6.4. So it's just another attempt to send additional signal.
So that is my second point that I want to bring up. So
okay, sorry, may I interrupt? I realized like I see why we might need this, because 87.671, like pref 6.4, saying, yeah, you need to use it in this order, but it only kind of applies to implementation which supports this. Exactly. What we're trying to say, please support this. It's a different question, right? Because if you have people who do not implement pref 6.4 not gonna read the order. Right. We actually trying to tell them it is recommended to implement this stuff.
So that is my second point. If you want to do that, the right place to do that is in 8504 BIS, which is happening in 6-man. If you want to like say like, hey, people doing V6 nodes should do it, we should have a discussion there, saying because like right now it has nothing about 7050. It's got nothing about like I think it only has like 4213 or something. You know the SIT mechanism. It doesn't have any other transition mechanism in there. I think we never had that conversation after that point, whether any transition mechanism need to be in the node requirements. But if you want to have that thing, I think that's the place to have the discussion about 8781. So
good point. So we're going to have the discussion on Friday. Perfect. Thank you, Suresh.
Lorenzo, just wanted to point out, whether you want to recommend this, you probably wouldn't get past IETF last call because the DNSOP people would like crucify you. But people do deploy this. You can use 7050 without DNS 6.4, and there are a number of deployments that do this. They just return, they just don't do DNS 6.4 except for IPv4 only.ARPA, and it works just fine. You know, whether you can get that past the DNS. Yeah. So basically, if you're a DNS recursive, if you see a query for IPv4 only.ARPA, you will synthesize. If you see any other query, you don't synthesize. And this is, I think Orange does this. Orange Poland does this. A variety of networks do this. Huh? If you've got the pref 6.4, right? So anyway, so the client will get the pref 6.4 by doing the 7050, gets the pref 6.4, and then it synthesizes, it does whatever it needs to do. Or it uses V4. It translated V4 through CLAT, for example. That's and the reason why they deployed this in Poland was that they found that their V6, their NAT 6.4 ALGs were way worse than their V4 NATs ALGs, and so they just wanted to use CLAT on the it's okay. It's in production. So that's something you could say. You could say if you must use 7050, you can get rid of DNS6.4 like this. You know, so that's something you could say, like just synthesize the code A only for IPv4 only.ARPA, not for other host names.
Oh, but that definitely sounds to me like DNS SOAP because it's basically recommendation to DNS server operator, right? It's outside of responsibility of network operator, outside of the host. It's basically how DNS server behaves. That's, yeah, it's interesting idea, but I'm not sure it's even in the scope of this draft if we keep it here.
It's possible that if DNS SOAP howls with rage at this this suggestion, they might get behind this one, right?
I mean, we're about to complete a full circle there because this started in DNS SOAP and they were actually thrilled with getting rid of this. Like, because my original suggestion was to make changes around how to use 7050, and they were like, we don't like 7050. Please stop doing it. And then we started raising questions about why did DS Lite lose out? That was the best. Outside of that, it was, we don't want to do this anymore. Because I agree with you, implementation-wise, the if-else logic is very simple, but I don't think we're going to see the DNS community being upset by this.
Okay.
Okay. So we will move on to
my next talk.
Yes.
Okay, good. I'm staying here. Yeah. Okay. You've seen that before. Well, the draft, I mean, and I hope you read it. But quick recap for those who were not paying attention before, right? What's the problem? What problem we are trying to solve? We have V6 only network. We have NAT64, also known as provider-side translation. We have V6 only host running CLAT, and both using the prefix, and I run traceroute, for example, from my machine. Everything north of the NAT64, right, which is dual stack, would respond with, and I'm doing traceroute over V4, like traceroute 8888. And obviously, dual stack host will respond, will be translated, CLAT will translate them, or at least it should translate them. But what's happened with intermediate nodes? They send you ICMP V6 from what I called in the draft, in this presentation, untranslatable address. It's a real V6 address which does not match a prefix, or NAT64 prefix. Your host does not have any static translation entries for this. So this is a normal V6 address which is getting dropped. And as a result, you obviously see in, like packet loss in your traceroute, right, which upset engineers. Yeah. So also, the same way, if in the unlucky event of any MTU problem on V6 only side, which indeed never happens, right? Your packet to be couldn't be translated, so you have no way of doing any like path-MTU discovery. So, what draft proposes? There are two things we're trying to do, right? First of all, define how to translate untranslatable, and draft basically saying let's use dedicated, already allocated by IANA IPv4 dummy address. And second question is how to preserve the original V6 addresses so they can be nicely represented in traceroute, for example. So, again, quick recap, how we can preserve IPv6 addresses in IPv4 ICMP when it's translated. We're suggesting to use ICMP extensions. So when packet is translated, ICMP extension header is added, and ICMP extension object is added into the packet. So, and there is a draft currently in interior which can do exactly that. There is an extension where you can define the node IP address. So basically what we are proposing, the NAT64 PLAT, CLAT. In this case, I'm gonna take ICMP V6 packet, translate it to ICMP v4 as it should, and also add an extension, either the whole extension element or just extension sub-object with original ICMP, original IPv6 address of the host. So if your application is smart enough to recognize it, it could nicely print you on the screen, and your users are not going to complain that they do not see any hops in traceroute. So what's new or old since last IETF? First of all, as it was been pointed out on the list, there is nothing new under the sun. Apparently, we already have RFC published by this group for exactly the same problem, with exactly this very similar solution, actually. Yes, Jeff just left. He was closer. What it was like, yeah, 12 years ago. Jeff, welcome back. We're talking about your RFCs. So yeah, proposal was, yeah, translate the packet and use another extension to preserve IPv6 address and use some real IPv4 address from NAT pool. What's the difference? Why the current version of this draft is actually trying to obsolete that RFC and saying, let's use our solution because I like it better? Well, first of all, I think we're using dummy address as kind of cleaner because it indicates to users that it's not a real hop. Secondly, I think the current, like 5837 says use like a real IP address from a pool. This would be applicable to PLAT size, which has actually public IPv4 addresses from the pool. In case of CLAT on a node, you don't have any public address to translate that V6 address to, right? So it's basically unapplicable. Also, that RFC actually suggesting using IP interface subobject. However, the original RFC defining that subobject saying that if packet is IPv4, then subobject must be IPv4. So strictly speaking, as I read it, if you're trying to insert IPv6 subobject into ICMPv4 packet, you'll be violating that RFC. So it's unclear to me how the implementations will treat that. Probably they will consider it invalid. So basically, to make the long story short, we're suggesting that we obsolete the previous work on this topic and proceed with this one. So finally, something new, right, since last time. Changes been made to the draft. Based on discussion we had in the room, we stopped over-specifying. We currently do not prescribe explicitly how to add those extensions. Appendix contains a suggested one possible approach. And the only thing we're defining currently is after you insert those extensions, your packet should look like that. How you do that, in which order? Do you add extension and then translate, or you translate and then add extensions? Up to implementation, does not matter, right? We do not really care about what the black box does. And we fix some typos, some editorial comments. And if people think that it's problem worth solving, we would like to ask for adoption. Warren. Warren doesn't look happy.
No, Warren has to admit that he got sidetracked into something else and missed part of the presentation.
Shall I repeat?
Yeah, all of it from the beginning. No, I just want to make sure that you and Bill Finner have been chatting because a lot of this is being discussed in an area, and I'm not quite sure why this would be adopted here.
Wait. We are using his extensions defined in an int area. What we are doing here, we are updating 7915, which is not 6.4 translation algorithm, which was defined in this group.
As I said, I was reading my mail.
You're welcome. Okay. Comments? Oh, some.
Q-Mizel, just out of interest, how well transported are ICMP extensions across the internet? Like, do middle boxes tend to drop them? What happens? Have you tested this?
No, we haven't tested that, but to be honest, I do hope that V6 only networks, unfortunately yet, normally sit somewhere between the middle box and the client, right? This is basically applicable if you look in the topology, right? Yeah, it's not internet, right? It's controlled environment, and those packets normally exist between PLAT and CLAT. So you are under control of this whole network.
Yes, but I can imagine a scenario where something in my V6 only network needs to send an ICMP packet.
Those packets are dropped anyway, right, currently? So they are just literally not translated, so it could not get worse. It could only get the same or better. So if some boxes do not like it, you would get the same result as today.
In my network, they are translated. They just get a dummy source address in them and send them out.
No, they couldn't get, like, we don't have, the only implementation which was implemented in the previous work on that, right, was using some real IPv4 addresses, which I believe CLAT cannot do anyway, right? So basically, okay, what worse could happen if they're dropped?
To jump in here. The packet in almost all cases only exists on the end host because this is on the v4 packet after the CLAT got to it and translated it back to v4. So it's only inside of, in the default case, your phone, and only your phone needs to get it from the CLAT to the application. If you have this translation ahead in the network, it needs to get to the v4 part of your network. In the v6 part of the network, you don't even see the extension. And if you have a v4 setup like this, you're running a very complicated v4 setup. You hopefully know what you're doing.
Okay, then I have misunderstood.
Yeah.
Tobias Hiebig, Max Planck Institute for Informatics, misunderstanding enthusiast. So I really like the draft because it feels like it is solving one of my problems, which happens to put what you want to see only in your controlled network on the internet. So if you do v4 with v6 next up, you basically have the same problem.
Yes, possibly.
With a tiny difference of those packets actually hitting like the internet out there. So I do kind of think that consideration of like what do we do with this and how far does it get is kind of important. I know that some people are dropping indeed extension headers, and I know that
those are not extension headers you are looking for. No, it's a different. We have name collision here. We have IPv6 extension headers. We have ICMP extension headers. I don't know why we name it the same way, but
beyond that, or dummy v4 address is also often considered bogon. Like just throwing this in here, that is not like negative for your draft for the use case it currently is focused on, but I do think that there is a use case beyond the single focus, and there that might be an interesting consideration.
We need to talk, but in general, basically, we are updating translation algorithm because apparently the previous work on this topic was saying it should be translated, but original like 79.15 was never updated. There is no new old text, so and we adding actually text what a translator should do.
The part again, Tobias, your part is in Bill's draft. It does actually say to use this on a next top if it doesn't have, like if it's generating error and it itself doesn't have a v4 address in a v6 only network. But in that case, there's no translation involved. It's directly generating the v4 packet. This one is about the translation specifically.
Okay, Q empty. Okay, so yeah, we'll reiterate. We'd like to ask for adoption, so it's up to chairs here to follow up on this.
Okay.
Thank you.
Now let's move on. Fernando, to you.
Can you hear me?
Yes.
Cool. So hi, I am Fernando Cont. I will be presenting the document problem statement about IPv6 support for multiple routers, multiple interfaces, and multiple prefixes. Next slide. Thank you. So an overall discussion of this document or the goal of this document, the motivation of this document. It has a number of pieces that we'll discuss like in the next few slides, but essentially the first thing that we want to do with this document is define the problem statement for IPv6 support of simple multi IPv6 scenarios. I use the term multi-IPv6 to refer to multiple routers, multiple interfaces, and multiple prefixes, so as not to repeat that long sentence a lot of times. Obviously, that of defining the problem statement, the goal is to, first of all, acknowledge the problem, and then so that we can figure if we can do something about it. Now, in the process of defining the problem statement, what this document does is define a limited number of simple scenarios that I believe that should be improved. And the reason for defining these scenarios or the goal of defining these simple scenarios is twofold. On the one hand, obviously, it serves to define the problem statement, but also the document spells out what should happen in each of these cases to actually improve the situation that we have. Then the other reason for defining these simple scenarios is for these scenarios to serve as test cases for any solution in this problem space. Okay. And then the last item that this document does is essentially call for action when it comes to protocol specification work. At least you would argue that that would be 6-man for at least for Slack to improve robustness for these simple multi IPv6 scenarios. And while this is, I'm not sure if this is spelled out clearly in the last revision of the document, but essentially what we have in mind here is to improve these scenarios with host side only improvements, like just improve things by improving what the hosts do, and not defining any kind of new mechanisms on the router side or any kind of new behavior on the router side, or define like new packet formats, new options, nothing new. And again, focus on these simple scenarios that we are defining in these documents. In this document, next slide, please. Next slide. So what is the problem here? I mean, I would say the most, if not of what I have in this slide, is well known virtually by anyone. Essentially, scenarios where you have like multiple routers, multiple interfaces, and or multiple prefixes are quite common, or some combination of that. They include, there are many of these, but among the possible scenarios, you could have, for example, a laptop that connects to the internet via an Ethernet card and a Wi-Fi, Wi-Fi interface. That could be one of them. You could also have like a simple scenario where you have a local network, just one switch, and you want to have, for example, two connections to the internet via two different ISPs for reliability reasons. And the problem here is that support for these scenarios has been poor, if at all present. You have some implementations that avoid breakage by implementing some hacks or workaround. That's valid, because at the very least that avoids like bad breakage. And they do things, for example, things such as only enabling on only using one interface at a time. So while in theory you have like a multi IPv6 scenario, if essentially you use a single interface, in principle you could change that to a non-multi IPv6 scenario. And in other cases where you have a multi IPv6 scenario and you don't implement one of those workarounds, things normally break badly. I believe that host robustness should be improved for these scenarios. I personally think of improving host robustness to these scenarios as a patch to Slack, if you wish. It's not like defining like a new functionality. We don't want, or at least when it comes to this document, we don't want like new fancy behavior. We just want some basic scenarios that you normally expect them to work, but currently break like very badly. We want to at least not break that badly, so to speak. Next slide, please. So this is one of the common scenarios that you would find with what I call here multi-IPv6, like multiple routers, multiple prefixes, or multiple interfaces. So what we have here is a local network. Let's say you have a switch in there, like a small office, and you want to have two upstream connections, so that if one of the your connection fails, somehow you start using the other one. You might also want to have something like that also for load sharing if you want. But let's say pick any of the two, like failover would also be fine. And in this diagram, what you have is like each ISP, just for illustration purposes, it has obviously a router. That would be your CPE router, the router that connects your network to the ISP. It has on the top like a recursive DNS server. Okay. And for the sake of illustration, these ISPs have a copy of the website example.com. So let's say that this site is being served by a CDN, and they have a cache on their at the ISP. Okay. Obviously, each of these two ISPs, have like different configuration information, different DNS servers, and so on. Even the instances for this website are different. And what you see, or what this host will see on the local network, is obviously the information that these two routers advertise. Now, when it comes to Slack as we know it, there's the assumption that the host that is on the local network will receive the information that these two routers are advertising, and somehow they will merge this information. They will aggregate this information as if this information could be used in any way. Now, in order to if you have never thought about this problem, if that's the case, I believe the problem becomes like evident if you kind of like revisit what are the actions that this host would take if it wants, for example, to contact the website example.com. So normally the first decision that decision or selection that it has to make is to pick a recursive DNS server. Second, second thing would be to pick a source address for your DNS queries. The third step would be to pick a next hop that you will use for sending your DNS queries. And now, if everything worked well and you have managed to resolve example.com into a set of IPv6 addresses, now you have to pick a source address for your, let's say, HTTP queries. And finally, you have to pick a next hop router for sending these packets. Obviously, in a case such as this one, if you have merged, if you have aggregated the configuration information all together, as is the case with Slack as we know it, things get like super tricky. For example, if you for example, pick to send your queries to the DNS server at ISP A, but you use the address space and the router that of ISP B to send your queries, well, your packets could easily get blocked because, for example, ISP A could have ACLs and only allow their own clients to access their DNS server. In a similar way, if you were to send packets using the address space from ISP A, but you try to send the packets through ISP B, then you would most likely, or you would expect them to be dropped because they would come across as source address spoofing. So if you think about all of these cases, there are a lot of combinations that if you get any of these wrong, normally things will fail, and they will fail badly. Next slide, please.
Fernando, Tim want to ask a question, so Tim,
Yeah.
please go ahead.
Yeah.
Hey, Fernando. I just wanted to ask, is there a reason you don't mention route information options in any of these scenarios?
It's just for simplicity's sake, but they are like in the document, they are mentioned too. So I just try to put like a little bit of information to the more obvious stuff, the less tricky stuff. But yeah, that applies to route information options too. Yeah. All Slack information actually.
Yeah, well, so I didn't see that mentioned because a lot of these scenarios are just removed if you process the route information options. That's something I think you should at least talk about.
In the document, as far as I remember, we talk about all Slack information. All. That includes like route information options too. Okay, next slide.
David, do you want to ask the question? Okay.
Next slide. And next slide too. So now what I will do, I will cover the scenarios that we have in the draft. As far as I remember, they are just 5. Here I will cover like half of them, like the ones that I believe are more like, simpler to see and more common and so on. And for time constraints, that's why I'm just discussing these ones. So first scenario that we expect to be handled in a better way. It's essentially the same scenario that I was describing in the previous slide. In the previous slides, okay, 2 different ISPs. You get like the 2 connections to your LAN, and then what's the expectation here, or how do I think that these problems should be solved? Essentially, I believe that the premise here is that the information that is announced by a router should be considered valid only for that router. So rather than actually trying to merge the information, the host should keep the information separate for each host that has advertised that information. Okay, not merge. That's why you see at the bottom of this slide, rather than having a single square, you have the 2. You don't mix the information. So that means, for example, that if you think about the steps that I was mentioning before, like the first thing of all is like to pick the recursive DNS server that you're going to use to resolve the domain name. Let's say that you were to select RDNSS A, the one of ISPA. So you made a choice in the information that you have in the block in yellow. That means that for every other of the choices that you have to make, you should pick data from the block that you have in yellow. You have to use the information all together, but not mix the information. That is kind of like essentially, extrapolating what RFC 8028 says, for example, about the relationship between prefixes and routers. This is just extrapolating the same idea, but to other Slack information. Next slide. Okay, so this is another different scenario. So there at least 2 cases where you could face this. So let's say that you have like the 2 different ISPs, and now things start failing with one of your connections. Okay. Essentially, there's nothing that actually, if you, for example, implement like 8028, which is like, so far the only advice that we have for this, there's nothing that currently tells you that, for example, when you are doing source address selection, that if all other things are equal, but one of the addresses will use an X-hop that is known to be reachable, and the other address would use an X-hop that is not reachable, there's nothing that we have right now that will make you pick the address that would use the reachable next hop. Okay? So how you could possibly solve this? You could think about like a rule 5.7, if you wish. And that would say that all other things being equal, if you have to decide among 2 addresses, 2 source addresses, and there's one that would use an X-hop that is known to be reachable, and another that would use an X-hop that is known to be unreachable or not known to be reachable, then use the address that would employ the next hop that is known to be reachable. Right now, as far as the current specs go, we don't have that. And you could be in situations where everything else that you do is fine, but then given these 2 options, you keep picking the address that would use the next hop that is not working. And even when you have another connection, things will just fail. Okay. And next slide, please. As far as I remember, this is the last scenario that I have in this slide, where essentially this is a case, for simplicity's sake. Let's say that now you have a situation where, same thing, you have a LAN, you have 2 upstreams, and let's assume that both of the routers are advertising the same information. The same information, I'm not saying a copy verbatim, but for example, the same IP addresses for the RDNS servers, and the same prefixes too. Okay, so two different routers, they announce the same prefixes, they announce the same recursive DNS servers, but now, for whatever reason, one of the routers advertised the same information, but now, for example, with a 0 lifetime. Okay, now with Slack, as we know it, that information with a 0 lifetime would cause the information to be completely removed. Because when you aggregate the information, that means information is invalid. And the argument here is that if things were implemented, as I was suggesting in the first few slides, you keep the data, the configuration information advertised by each router separately. It's not just the information, but also the timers are separate. So if the router, if the ISP-B router were to advertise configuration information with a lifetime of 0, you disassociate the information with that particular router, but there's no reason for which you shouldn't be able to use the same information with router A, because for router A is claiming that that information is valid for it. Okay. Next slide. So that's it for my side. So big comments, questions on whether the working group considers this to be useful.
David Lamparter, Rule 5.5 enthusiast. You're referencing 8028, and 8028 directly references Rule 5.5, which I will say is incredibly little text for an incredible whole lot of consequence from it. And also 8028, if you follow the train of thought to the ultimate end, it boils down to source destination routing. It doesn't say that, but if you think through and actually try to implement it, that is what you arrive at. And the entirety of this topic has been frazzled with things that sound easy, but if you actually put all the effort in, turn out to be quite hard. And I absolutely agree that we should do something like your document, and I agree with the direction. I will say you need to be very careful to be specific, think through how this is actually going to be implemented, how it's actually supposed to work, as to not add more to this already complicated situation.
Yeah.
Pat.
Ted Lemon. So a couple things. One, I read your prior work section. I noticed that it does not reference RFC 7556 or RFC 8801, both of which are key work in this area that actually describe a bunch of the stuff that you just described in your slides. I think it would be worthwhile to incorporate that. I think the other stuff you talked about here is good, and I support the work, but I'd like us to not reinvent the wheel.
Mm-hmm.
No hats. I'm glad Ted said that, because that's basically what I was going to say. 7556 and 8801 plus 7556 also had implicit PBDs. So I kind of was wondering what was new that wasn't in that work already. I mean, I know we're missing implementation, but that's kind of a different matter. So anyway.
You know, one of the things, for example, I don't know if you were, I don't remember the numbers off the top of my head, but for example, there's PBD, of course, provisioning domains, but it tries, for example, like if you think about provisioning domains, like for the most part, it's focusing on explicit provisioning domains, where you could argue that and it defaults for implicit provisioning domains. It assumes that a provisioning domain is associated with an interface, whereas essentially in this case, we only focus on implicit provisioning domains.
No.
There's no.
I think the text was that implicit PBDs were per originated source of information. I think so, per originated array. But it's been a long time since the MIF working group, so I could be mistaken.
Mm-hmm.
Hello, Fernando. Tom Hill from BT. We happen to have a very large fixed line network and a very large mobile network. And we do provide a consumer product that has active backup, active passive failover. So the fixed line connection goes down, the mobile connection comes up. Now, for whatever reason, they do not give the same prefix, or they wouldn't give the same prefix from the same range or anything like that. They would have two completely different V6 prefixes sent in. So, of course, we have a problem where we have, as per one of your solutions, your designs there was we have to be able to switch the V6 connectivity from one disparate network to another. It's within our control though, which is quite interesting. The thing that I've not seen in any of your documents, either the spec or the problem statement, is anything to do with globally unique link local addresses, the gateway addresses. So one of my hopes was that we could start testing actually changing changing the local address over whenever we have one of these situations where the fixed line connectivity goes down, and forcing that update of source selection. So is this something that you could introduce into the document as something we could use?
The problem is, short version of the story, spoiler, if you don't have rule 5.7 that I described, that doesn't work. Because you'd have two routers, each of them would be used for the different prefixes, but there's nothing that makes you pick the one that is actually working. So you have that of picking the working next hop router if you have multiple routes, but for the same source address. In the case you describe, you'd have different prefixes. Each of them would have a single next hop router. If you don't have that rule 5.7 that I described, that doesn't work.
I can hear Jen behind me getting very excited, but from a logical standpoint, just the fact that the hosts might not implement that at the moment doesn't mean to say that we shouldn't talk about it within this draft.
Yeah. But what I'm saying is that, with what's, in there, and the other thing is, the premise here is that try to improve things without having to rely on the router doing something else.
No,
Otherwise, it's like, okay, the router doesn't implement the fix, you're toast.
It is incumbent upon us to try and make things better and more compliant. So, yeah, okay, I'll cede to Jen anyway. Thank you.
Jen Linkova. Yeah, Fernand, I know we discussed that, but first of all, I think we still disagree on the selection logic, because I still believe that host would not select unreachable gateway, and as a result of Rule 5.5, it would not select a prefix advertised by that unreachable gateway, right? Yes, you need Rule 5.5, but without Rule 5.5, that stuff, it just does not work. We have to accept the fact that devices do not support in Rule 5.5 not gonna work in that scenario. That's fine. However, I think it would be nice if your draft does two things. First of all, one of scenarios you describing is clearly misconfiguration, right? When devices advertising conflicting information and they are under the same administrative control, it's like clear misconfig. Like, just don't do this, right? Doctor, it hurts when I do this. Just don't, right? Secondly, I'd like to, second questions which been asked, would be nice to emphasize what's new, because yeah, it's been a lot of work done on PVD. Before PVD work was done, I happened to co-author a document about multi-homing, which was talking about more or less the same thing. So it would be nice if your document focus on things which have not been said before, or maybe summarizing them, because yeah, people might get confused what exactly new scenarios we're talking about. Thank you.
Good point.
Jeff Houston, look, in a previous life, I was a co-chair of SHIM6 with, of all people, Curtis Lindquist. And that effort actually came up with 3 RFCs, 5535, 5534, and might have even been 5533. Don't really care. There was a long effort at the time around multi-homing in IPv6, multi-6 and all that. It was a bunch of discussion. And eventually it came into a set of specifications in a charter that said, let's do it in the host. Let's require no changes in the outbound protocol, any part of the packet, no extension headers, nothing out of the network. It required us to actually do multi-homing in such a way that your scenario 5 was true, that you could actually change the exit router and still keep a connection running to the other end. Why am I feeling like we're reinventing all that stuff with your work here? Why is this sort of revisiting necessarily a good thing to spend time on? Because the problems of SHIM6 back in 2006 were not the quality of the protocols or the mechanisms. The real push was that ISPs were completely opposed to a mechanism that placed the power of exit selection into hosts, which I think was one of your slide scenarios, that you wanted a host-based mechanism. Shim6 failed because it was precisely host-based. There's no commanding rule out there that was going to say use exit A, use exit B. It was up to the host. So it seems that this is a lot of ground that was painfully covered years ago, and it was painful, very painful. And I'm not sure that I see anything new in what you're saying here that would attack this from a different perspective. Now, maybe I'm wrong, maybe you've read it through, maybe you have some new insights, but from where I'm sitting here, I'm sorry, I must have missed it. Thanks.
Bob Hinton, yeah, I don't have a lot more to say than what Jeff just said, but this topic has been a very long, this topic has been going on as long as I've been in the IETF, which is for sort of forever. And it's a very interesting topic. I personally think the only way to really solve it is to get hosts involved in routing, which is definitely way out of scope of here. And this is where the internet area meets the routing area and doesn't necessarily play well. So I'm the only thing I'm pretty sure is probably V6OPS is not really the place to do this, but it would be good if we could solve it in a way that could be deployed, as Jeff says.
No, this is just the problem statement, not the protocol work, okay?
But I just want to quickly comment on Bob. That's why our enterprise multi-homing draft, which was like 60 pages long, ended up in the routing working group, actually, not even in V6OPS, right? So we did consider it from both routing and V6 Slack perspective.
Okay. We need to move on. Okay. So
Hello, this is Peng Zhan from ChinaUcom. Today I want to share the latest IPv6 network deployment monitoring and analysis advancement. Our proposal is to our object is to drive the growth of IPv6 traffic and also the shortcoming in IPv6 deployment. Current IPv6 network deployment analysis often highlight technical gaps in IPv4 to IPv6 transition. Yet, here is a significant gap in IPv6 support status exists in different network scenarios. The absence of comprehensive tools for end-to-end IPv6 deployment monitoring and analysis across clouds, networks, edges, and terminals hinders multi-dimensional and in-depth monitoring and analysis. Before this meeting, we integrated two drafts into the first one is the IPv6 monitoring deployment, and the other one is the use case of IPv6 monitoring. We did a presentation last time in Dublin. First, we refined the problem statement. We add a summary of the current approaches to monitoring IPv6 deployment. And in section 3, we proposed an IPv6 end-to-end monitoring and analysis system. Here is already many different IPv6 monitoring systems, such as the Internet Society Pulse, the Academy IPv6 adoption. But actually, our IPv6 monitoring and analysis system is different. They have different proposals and different means and different requirements. So we proposed an IPv6 end-to-end monitoring and analysis system. It can meet many different requirements, and the core functions are listed, such as quality IPv6 deployment maturity through key performance indicators, and it can enable cross-domain data integration. It adopts a multi-dimensional analysis methodology to perform root cause analysis. It optimizes development mechanisms based on analysis results. And most current systems are local index analysis. In order to more comprehensively show IPv6 deployment status and analyze the bottlenecks and blocking points of IPv6 deployment, we have newly defined a complete set of key performance indicators, including the readiness indicators and operational metrics and quality metrics. The readiness indicators include the network element readiness and infrastructure readiness, cloud readiness, application readiness, and network readiness. The operational metrics include the IPv6 traffic and active IPv6 connections. The quality metrics include the DNS resolution performance and end-to-end latency and packet loss ratio. Also, here is a question: why is cross-domain integration necessary? I think it's because the IPv6 is not merely an issue concerning network and terminals. Rather, it's an end-to-end problem. So we put many different domains into consideration, such as the home network domain, the mobile network domain, and the IP-bearer network domain and application domain. They have different focus. And another question is, why is multi-dimensional analysis methodology necessary? It's because we should avoid the limitation of single-dimension analysis. The IPv6 network environment is complex, involving numerous network devices, diverse application services, and a massive number of users. The multi-dimensional analysis model enables comprehensive monitoring and analysis from multiple perspectives, such as network topology, traffic types, user behavior, and time dimension. The approach allows for obtaining a comprehensive and accurate view of the network status. Here is use case. We use the system to do the homework terminal traffic analysis. The result, we analyze the traffic in our home network and mobile network in a specific area. And the results revealed that the IPv6 traffic in home network lags far from mobile networks. From fine-grained multi-dimensional analysis, we can find the root cause. It's the insufficient IPv6 support in home routers. So what can we do? We can highlight the need for device-level IPv6 support upgrades. What's next? I think we will propose something more in the next meeting or sometime, including the technical implementation detail of the system, the effects of the system can achieve, and the display of the system's interface. Think about the standardization direction, I think, including the explore the content of requests and response for data interaction between network management systems through standardized interface. So welcome comments and coordination. Thank you all.
Any questions or comments? Well, if not, I think we can end the meeting here.
May I have a last question for our responsible lady, Warren? Can you confirm, just a question for you, can you confirm this is your last working group meeting as the Ops AD now? should know. Yeah. Yeah, just one thing. One more thing.
Thank you, Warren. Okay, thank you, folks. Thank you.